Welcome to our comprehensive lesson on matrices for Class 12. In this video, we'll cover the entire chapter from basic concepts to advanced operations. Let's begin with understanding what a matrix is. A matrix is a rectangular array of numbers, symbols, or expressions arranged in rows and columns. For example, here is a 2x3 matrix, which has 2 rows and 3 columns. Now, let's talk about matrix notation and terminology. We typically represent matrices with capital letters like A, B, or C. The individual numbers in a matrix are called elements or entries. The order or dimension of a matrix is represented as m times n, where m is the number of rows and n is the number of columns. Let's explore the different types of matrices. A row matrix has only one row. A column matrix has only one column. A square matrix has an equal number of rows and columns. A diagonal matrix is a square matrix where all non-diagonal elements are 0. An identity matrix is a special diagonal matrix with 1s on the main diagonal and 0s elsewhere. A 0 matrix contains all 0 elements. Now, let's learn about matrix operations. To add or subtract two matrices, they must have the same order or dimensions. Matrix addition is performed by adding the corresponding elements. Similarly, matrix subtraction is done by subtracting corresponding elements. Let's move on to matrix multiplication, which is more complex than addition or subtraction. For two matrices to be multiplied, the number of columns in the first matrix must equal the number of rows in the second matrix. Let's say we have matrix A with dimensions 2x3 and matrix B with dimensions 3x2. The multiplication process involves taking the dot product of each row of the first matrix with each column of the second matrix. Now, let's discuss some important properties of matrix operations. Matrix addition is commutative. A plus B equals B plus A. Matrix addition is associative. A plus B plus C equals A plus B plus C. Matrix multiplication is associative. A times B times C equals A times B times C. The distributive property applies. A times B plus C equals A times B plus A times C. However, matrix multiplication is generally not commutative. A times B is not equal to B times A in most cases. The transpose of a matrix is obtained by changing its rows into columns or columns into rows. If A is an m times n matrix, then its transpose is an n times m matrix. The transpose is denoted by a transpose or a superscript T. Let's look at an example. If we have matrix A, then its transpose would look like this. Now, let's learn about the determinant of a matrix, which is a special number calculated from a square matrix. The determinant is a scalar value that can be calculated from the elements of a square matrix. For a 2x2 matrix, the determinant is calculated as a times D minus B times C. For a 3x3 matrix, we use the method of cofactors. Let's now learn about the inverse of a matrix. The inverse of a square matrix, A, is denoted by A inverse, such that a times A inverse equals the identity matrix. Not every matrix has an inverse. A matrix has an inverse if, and only if its determinant is non-zero. For a 2x2 matrix, we can calculate the inverse using this formula. Finally, let's discuss some applications of matrices. Matrices are used to solve systems of linear equations. They represent geometric transformations like rotations, reflections, and scaling. In graph theory, matrices represent connectivity between nodes. Matrices are crucial in computer graphics, machine learning, and data analysis. That wraps up our comprehensive lesson on matrices for Class 12. We've covered the basic concepts, types of matrices, matrix operations, properties, and applications. Remember to practice solving different types of matrix problems to strengthen your understanding. Thank you for watching.